This term corresponding to flipping. This term corresponds to the fact that my body is shifting. Okay? So this formula is useful. And it's worth spending all the time to just like a particle, we have energy conservation. We also have energy conservation for a system. So remember, we first look at how work affects kinetic energy. Then we say some of the work is easy to compute, and we call those potential energy. Same with here, but a little bit more complicated. To change the total energy, to change the total kinetic energy, you look at the change of individual kinetic energy summing together. Right? Now, the change of those kinetic energy will be the work done on the first particle and the work done on the second particle and the work done on the nth particle. That's the work kinetic energy theorem. Now, within this work, some of them come from external force, and some of them come from internal force. Remember, internal force and external force is the force from particle inside the system or outside the system. The force between the particles is internal force, but there are some other force coming out of the system. Those are external force. So they all can do work on the particle, so we separate it. The second particle also has external and internal. And yeah, just write it down. Now, we're going to assume that all the internal force are conservative. And I'm going to call the sum of internal work with a minus sign as the change of internal potential energy. It is like when you have two particles connected with a spring, then you can say they are having potential energy because there's a spring between them. That's internal potential energy. So now the equation becomes the change of total kinetic energy equals the internal force, internal work plus external work. I'm going to move the internal work to the other side, so I have minus the sum of internal work. And that will equal to the rest of the external work. 1 external. Okay. The change of kinetic energy equals the work done on all the particles. I call those done by internal forces as internal work and move it to the other side. So now this sum of internal work with a minus sign will be called change of internal energy, internal potential energy. Okay? Now, on the right hand side are all the external forces. External forces include gravity, air resistance, blah, blah, blah. The key is that there will be external work done by conservative force and external work done by non-conservative force. Okay? C is C stands for conservative, and F stands for non-conservative because usually friction is non-conservative, usually. And they are just splitting all the work done on, all the external work done on the first particle. So the external work done on the first particle will be split into the external work that is conservative done on the first particle plus the non-external, non-conservative force that is external done on the first particle. So we split every term up here into two terms. This going to here, this going to here. Okay? And now we're going to call the work done by external conservative force with a minus sign as the change of external potential energy. So finally, we get to total change of kinetic energy plus the change of internal potential energy equals this plus this. But I'm going to move this to the other side and get a minus sign, which I call the change of external potential energy. And that equals to the work done by external non-conservative force. That's it. And remember, total kinetic energy is the kinetic energy of center of mass plus the internal kinetic energy. So at the end, I get the work done by external conservative force, external non-conservative force will equal to the change of total energy, which include the kinetic energy of the center of mass plus internal energy, which is the sum of internal kinetic energy plus internal potential energy. Then there's going to be the external potential energy. So that's the energy conservation for system. If you compare it with a particle, this is a system. For a particle, you only have non-conservative work equals the change of kinetic plus potential energy. For a system, the difference is this internal energy. A system has a lot of particles, so even from the outside, there's not a lot of things going on. There might be a lot of complicated things happening inside the system. The thing inside the system might be doing windmill. So even though from the outside it's not moving, it has internal kinetic energy. The particle inside the system might be having some interaction between each other, and those give you internal potential energy. So that's the difference between a particle and a system. If I have this bottle and I raise this bottle up, the center of mass is higher. That corresponds to the external potential energy. When you drop down, the center of mass is moving. That corresponds to the center of mass kinetic energy. When the water has a vortex in there, the bottle is not moving, but you know it has some kinetic energy in there. Those are internal kinetic energy. When you evaporate it, you can heat up the bottle and make the water particle have some bigger distance because they turn into gas. Those are internal potential energy. Okay? So basically, if you know you have done work to a system so that the energy of the system should increase, but you didn't see, so I've done work to a system, your energy should be bigger now, but I don't see your kinetic, I don't see your center of mass moving, I don't see your center of mass being higher, then I'll just spend everything into the internal energy. And if the internal energy comes from the internal motion, it's kinetic, others exponential. I need to get to this because I want to talk about the agricultural system. So for an agricultural system, what you're doing is to harvest the energy from sunlight particles. Sunlight is a bunch of particles. They come into Earth and give us sunburn. That is not a good way to use that energy. So we want to convert this energy into some form that we can use. Energy has different form. Sunburn is not a useful form of sunlight energy. So we plant some crops, and in the leaves, the particles inside the leaf will have some special type of interaction called photosynthesis that turns the energy from the sunlight is going to be an external work into the internal energy of the leaf particle or the particle inside the crop. And the leaf is not doing windmill, so you know it is the internal potential energy that goes up. And it is good